Good morning and good afternoon, wherever you are. The topic of our research is automatic detection and extraction of lung cancer. Just a minute, I have a problem with lung cancer nodules using connected components labeling and distance measure-based classification. The research is conducted by me, Mamdouh, Kinan, and Waad and Maan at Andalus University for Medical Sciences and the Faculty of Biomedical Engineering in Al-Qadmus, Syria. The presentation include introduction, related works, nodules, automatic extraction method, shapes and density features, results, and discussion and conclusion. Just a minute, I have a problem with this one. Okay. Sharing. Just a minute, please. Okay, okay. Lung cancer, according to the WHO statistic in 2013, lung cancer became the most dangerous disease and even surpassing breast cancer. Early diagnosis, as we know, early diagnosis can improve the effectiveness of treatment and the patient's chances of survival. So lung cancer has become a major concern for both concerned specialists and computer-aided diagnosis developers. As a result, hundreds of papers were published in the past 3 decades on automated lung cancer detection. In general, most of review papers focused on calling for further improvement in the performance of the available LC-CAD systems, especially in segmentation of lungs from chest images and in detection of lungs nodules. That means segmenting and detecting nodules from lung images. And also most of review papers focused also on considering these improvements as challenge for further investigation in this field. In our research, an automatic method was introduced for detecting and extraction of lung cancer nodules from chest CT images. The method provides highly accurate segmentation of lungs from from chest CT images and accepts various shapes and sizes of lungs. That leads to more flexibility and effectiveness. The method uses 2D connected component. The method uses 2D connected component labeling technique to extract the lungs area from chest image, and uses also a weighted distance measure-based classification technique to detect nodules with high accuracy. Related works, among hundreds of papers, we will mention some of the important works in this domain from our point of view, like HOMA NTL in 2008 used Gabor filter and the difference of pixel values along the object axis to detect nodules. Also, Gomathy in 2010 used fuzzy possibilistic C-main and extreme learning machine. And Wong in 2020 used residual network, neural network. Also, other used principal component analysis and watershed technique and density features, histogram, and some morphological operator And all works mentioned previously give an idea about the diversity of techniques and methods used. In 2011, Maan used the CCL, also connected component labeling technique, to extract liver area from the complicated 2D abdominal CT image for liver cancer diagnosis. Based on this experience, we explored the possibility of using the same technique, that means CCL, for detection and extraction of lung cancer nodules from 2D chest CT images, and presented the encouraging results in this paper. The data collected and used were the images from lung CT images of 11 persons from Al-Sham Center, Imaging Center, and 102 persons from Tishreen Hospital. About 80 images was used. Specialists selected one image from each scan for this study. 113 images were divided into two groups. The first group was contained 98 from lung cancer patients, that means with nodules. This group used for developing and testing the algorithm. And the second group contained 15 from healthy persons, that mean no nodules. And this group is used for consistency check. Both groups were used for lung area extraction from CT image. We can see here two images, one with lung CT images of healthy person left, or I show to this image, and the other is a lung CT image with a cancer patient, and the four circles shows the diagnosed nodules diagnosed by the doctor. Nodules automatic extraction. Nodules automatic extraction include two stages. The first one is lung area extraction, and the second stage is nodules detection and extraction. We can see here the input image, lung area extraction, and nodules detection and extraction. Here is the output with 4 nodules that diagnosed in the previous slide. With the specialists. Lung area extraction stage consists of 8 steps. From the input image that here A is the original image, then followed by thresholding used also method, then large area detection by connected component labeling, then followed by an closing process, filling process, opening process, for also to remove the small nodes or nodules, as a closing process, and the lung mask, and in the eye is the output of the stage, the extracted lungs area. Here in this slide, we can see original CT images and many various shapes and different shapes and sizes of lungs that will extracted by the method with very good accuracy. Extraction of nodules from lungs images contain of 3 main stages. First, preparing the lung area image for feature extraction. Second, extracting features used for classification. And the third stage is classifying the regions remaining in the prepared image into nodules and not nodules. Preparing the lung area for feature extraction contain of 3 stages: automatic thresholding, connected component labeling, small components removal, and the image containing remind connected components to be used for feature and nodule extraction in second stage. Sample results we can see here. Left is the extracted lungs images. Here is a binarized image with many small nodules that can mean cancer nodules or regions that can analyzed as nodules, cancer nodules and non-cancer nodules, and is the output remaining CCs after small components removing will be used for feature extraction. Here is the shape features used in the study. From F1 is a form factor to F6 aspect ratio. These features known for all. Here is the density features also used. FD1 is the normalized moment, the force normalized moment, and third one, standard deviation, smoothness measure, similarity measure, entropy, and used for extraction. Detection of nodules from extracted lungs with remaining CCs. Remaining CCs contains nodules and not nodules, and separating between them is a standard 2 classes problem. Similar to signature verification system, forgery or genuine, developed by Maan in 2002, based on the threshold on the weighted Euclidean distance. We use the same approach. We use the same approach to separate nodules from non-nodules. Nodules components were detected by computing the WED, weighted Euclidean distance, of each CC in the image using shape and density feature explained in the previous 2 slides. Then, using a global threshold obtained from the training group, we classified HCC. HCC with the distance less than global threshold means nodules, otherwise is non-nodules. That means either equal to the GTH or more larger the GTH. The group training to obtain is done on 30 images among the 98 ones containing nodules diagnosed by the specialist doctor, and in the table contain the results of the shape feature and density feature of a simple case 4 mentioned previously. That means the shape feature values and WED for simple case 4 CCs. T, that means in this case, the doctor says is here is a nodules detected. Results and discussion in this table feature kind in the first row, and in the second and third row is the shape features and shape and density features. As we can see here, the sensitivity when we use shape features is 95.1%, and when we use shape and density feature is improved to 97.2%. FPS, our false positives per case was, when we used shape features, 2.1, number of CC connected component was 1,836, and number of nodules diagnosed by doctor was 173. When we used shape features plus density features, the false positive improved to 1.98, and the same number of CCs and same number of nodules diagnosed by doctor. We can see from this table an average diagnosed nodules is about 2.54 per image, an average number of remaining CCs in an image is 27. False positive is a false alarm, but it is not so dangerous, and in contrast, maybe give more careful to be considered. Density feature about 2% sensitivity improvement, and false positive is about 6% improvement. To verify that the method works, probably a performance consistency check of the nodule detection and extraction algorithm was done. The method was tested using lung images of the 15 healthy persons, and the results was promising, where 9 false positives appeared in 8 images, that 4% of connected components as an average. As example for the performance consistency check, the first row contains the images from a patient with true positive of 7 and false positive of 1, where we see here 7 nodules diagnosed by a doctor, and the system detected 8. That means 1 false positive. That means this point was diagnosed as a cancer nodule, but in the true is not a cancer nodule. In the second row, we can see the image of a healthy person where TP true positive is 0 and false positive is 0. That means no nodules, and the detection was perfect. As we see in the last image here, is no nodules was detected in the whole image. As a comparison with some other works, we comparison our works with 8 or 9 works from 2010 to 2020. We can see our works is better in the sensitivity and is better with 97.2% sensitivity, and false positive with 2.1 for number of nodules 173. As future work, it's recommended to conduct additional research in improving the performance of the classification by using the feature selection technique developed by Ammar in 2011. Conclusion: a high performance method was introduced for the automatic extraction of lungs area from CT image using connected component labeling and morphological operators with a wide variety of lung size and shape. Also, a combination of connected component labeling and weighted Euclidean distance-based classification were used to automatically detect cancer nodules from extracted lungs area with high accuracy. The high performance of whole method was supported by demonstrating the ability to detect the healthy image at the same time. As last conclusion, using density features with shape feature together improved the performance of the method. Here is the references we used, and